programming problem, has a lot more pizzazz. You can only ever have one function. Could never have more than one function. Will you graph the 3x plus 2y? No, you only graph inequalities, you don't graph the function. But, okay, so how many inequalities am I actually going to graph here? I hear 4. Anybody want to argue?
No, 5.
Yeah, this one, the negative 2 is less than x is less than 10, that's actually 2 that they have combined together into 1. But, it's really, really easy to graph. What kind of lines are x equals lines? Horizontal or vertical? Those are vertical. So, if I'm going to graph this, and it's saying x has to fall between negative 2 and 10, that means I've got a vertical line at negative 2 and a vertical line at 10. So, we're literally going to go put vertical lines at each of those numbers. Negative 2 and 10. Okay, so where should you be shading if it's written with x between negative 2 and 10? Yeah, the shading's in between. Once again, don't go hog wild crazy on your shading because it gets so busy. This one's going to get a lot busier than the last one. I'm just going to shade here to the left, or excuse me, to the right of this one, to the left of 10, showing that, okay, I would be shading in toward the middle there, between those two black lines. I highlighted my origin just so I don't lose it. I think that really helps. Once you start putting on those horizontal and vertical lines, I have people starting to find where they intersect and count from that as the origin. It royally messes up your problem if you're counting from the wrong spot. Alright, so then I need y is greater than or equal to negative 2. What kind of line is it? It's the horizontal line at negative 2. So, and since it's y is greater than or equal to negative 2, which way would I shade? That one's also an up. So right now, all 3 of those would be intersecting between our 2 vertical lines. So I kind of got 3 sides of a rectangle here formed. My shaded region would be somewhere in the middle of all 3 of those. But I still have 2 inequalities to go. So how many sided figure do you think this is going to be? 5. Typically 5. Doesn't have to. The most it could be is 5-sided. But these other 2 they have both x and y variables. So how am I going to get 4x plus 5y is less than 45 graphs? Yeah, a little table action here. So if you put 0 in for x, it's nice. The 4x is gone. 5y equals 45. If I divide by 5, I'll have 9. No big deal. If I put 0 in for y, 45 divided by 4 is, okay, 4 times 11 is 44. Well, let's try 11 and 1/4, which would be 7.25. Okay. So, alright, counting from the real origin, 0 over and 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9 is up there. And wow, then 11.25 over. Well, I know this one line up here is at 10 over, so 11.25 is going to be a little bit past that. You're going to probably want a straight edge on these because you need to be able to draw fairly accurately. You moved it the last one, but I think it'll be okay. Okay, but this one, you can probably guess where you hope it shades, but we better make sure that it shades in the direction we want. So how would I test this one to know where it shades? I would put 0, 0 in myself. So if I do 4 times 0 plus 5 times 0, that's going to be 0 is less than or equal to 45. I believe that's true. So, yep, we are shading toward 0, 0, which means are we starting to form an enclosed region? In fact, we already have an enclosed region. So what's the other one going to do? Maybe it may make this region get smaller. That's a very good observation. It's going to limit it somehow. So, okay, this last one. In this case where it's y by itself, I probably would just add the 2x over, because you pretty much can't screw that up solving for it. Which means I would start at 9 and do what? Which I'm kind of, up 2 over 1 doesn't give me any options. I believe I'll do some down 2 left ones, so I can get some more points on there. And draw that line in. And how do I decide where that one's going to shade? Okay, it is y is less than, so it's going to be below. Or you can test it. If I substitute 0, 0 in there, is 0 less than 0 plus 9? Yeah, 0 is less than 9, that's true. So I need to shade toward 0, 0, which means I'm on this side of the line. Then, now that you've got them all on there, and if they're all shading in toward the middle, so you know it encloses a region, you need to go find the outline of that region, because it's really hard to mislead yourself. I'm going to start down here in the bottom left corner where the horizontal and vertical line intersect. I can see that I'm going to come across there. I'm going to hit a vertical line and go up. Then I'm going to hit the diagonal line, come across most of the top. But once I hit the peak, I come back down until I hit the vertical line again, and I come back down the vertical line. So I'm talking about that whole region in there, but I just obliterated my origin, so I'm making my origin show up again. That's a kind of bigger region than we got last time. So, now what? You need to find the points of vertices. So we need to find all the places where this thing had a corner and went in another direction. Okay. So counting from the old original origin, this bottom left corner is left 2, down, should be down 2. The one to its right, I know that vertical line was at 10, so it must be 10 over and down 2. The one right above it is 10 over, but up how many? Up 1. Then, back to the very top one, it's straight above the origin, so it's 0 over, and we counted up there to 9 several times, so it's got to be 0, 9. And lastly, this one off to the upper left is negative 2 over and 1, 2, 3, 4, 5 up. And you found your vertices. Okay, then the big question. Why did we find them? What do we do with them? Plug them back in what? The function. So I'm going to do the function at negative 2, negative 2. The function at 10, negative 2. Function at 10, 1. 0, 9. And negative 2, 5. And what do I do with them? I need to plug them in the function. I should have rewritten the function down here where I can see it. I'm going to recopy the function here so I can see what I'm doing. It is 3x plus 2y. Anybody want to place bets on what's going to get us the maximum or the minimum? Okay, let's try and see. So if I substitute negative 2 in for both x and y in the function, that's negative 6 plus negative 4. That's negative 10. Okay. If I substitute in positive 10 but negative 2, that's 30 plus negative 4 would be 26. Okay. 10 in plus just 1 in, that's going to be 30 plus 2 is, anybody placing bets on 0, 9? Well, 0 plus 18 is just 18. And last but not least, putting in negative 2, 5. It's going to give us negative 6 plus 10. So we get just 4. Okay, and when you're working these ones that are just graphing, all you need to say for a final answer is, okay, I got a maximum value of what? What was the highest value we saw here? At what point? At 10, 32 happened at 10, 1. And I got a minimum value. What was our lowest? Negative 10, yes. At negative 2, negative 2. And ta-da! You have solved your linear programming problem. Okay, now, is it important that you graph fairly accurately? Yeah, this is not one you can just flop. Because you've got to find those points where they're intersecting each other. You've got to be fairly accurate about graphing this. That's a little bit the downside.